Hi folks, Chuck Black here. We are doing quokka walkthrough. We are on walkthrough number 6. And here's a question. Did you ever wonder where all of this data actually came from? I mean, something must be happening in the background, right? To cause all of this data, whether it's, within the last hour or whatever, and then this is even within the last day or so. Where's all that data come from? Well, the answer is it comes from background threads that are running within quokka that gather all of that interesting information and store it. Not only this, but configuration information, compliance information, etc. And so what we're going to be doing in this lesson is looking at how exactly that stuff gets initiated. And we'll take a little quick peek into how it actually works. Not a deep dive into the threading, but just a high-level overview. So hopefully this will give you a little of idea about where all this interesting data is coming from and will be of benefit to you as you learn more about how quokka does what it does, and hopefully adding to your skill set in the realm of software development. Enjoy. Okay, so today we're talking about the creation of a number of threads that do a number of things for us. Remember, we are going through this init module, which gets called at startup when Flask begins to run for quokka. Things that we've done: we've created our Flask application, we've imported all of these environment variables for various intervals, we created our database connectivity, we defined our views, we came through and then we read configuration information about devices, compliance services, workers, etc. And that brings us to the next thing that we're going to do, which is what I'm highlighting right here, which is starting of a number of threads that are going to be running in the background. So a web application typically just sits there and waits for requests to come in based on the views that we've defined and responds to those. But we're more than just a standard web application. We're attempting to constantly be going out to the network and monitoring devices, monitoring the compliance, getting configurations so we can do config diffs. We want to be monitoring services. We want to be discovering devices. We want to be monitoring the hosts that we've discovered. We have summary processes, summary task that goes out and gathers hourly information about the different status data that we've been collecting. We have workers that we're maintaining information about, and we are maintaining our database. That is, we're deleting old records from the database so that you can run this pretty much forever and not have to worry about it blowing up your system because it stored too much data. We trim off stuff that isn't needed. So that's what we're going to be talking about in a little bit more detail as we go through this. Now, some of the stuff I'm going to be talking about here, I'm going to be going in general at a relatively high level. We're not going to look into some of the different nuances of how I have implemented the management of all of these threads. I'll go over it a little bit, but we won't go into too much detail. But I just want you to be prepared that we are going to be looking at things that may be new to you if you're a new person. If you, new person, not like a new person, like a baby, I'm assuming you're not, unless you're some type of really intelligent baby. But if you're a new person to software development, then this may be new to you. If you are an experienced software developer, then you may agree or disagree with the way that I've done it. And we're not going to go into too much detail about that, but I do want you to have a general idea about what exactly is going on. So let's begin to look at what we're doing here. The first item that I want us to look at is this thing I have highlighted, which you can tell is an import statement. And what I'm saying is from my code here, quokka controller thread manager. If I go up here to quokka controller, I'll see that there's something called a thread manager. I'm going to import something called a thread manager. Now, one thing that you'll notice is this name looks a little bit different than other names that we've used in the past. You know, when we're using regular Python variables, what do? We use this underscore character to separate the different parts of the variable name. So if we have different words here, we use an underscore. We call that snake casing. And you see I'm not doing that here. Rather, I'm doing what we call camel casing, where you capitalize the letters of each word. So thread manager has a capital M there for manager. So that's going to be an indication that this is actually a class. If I was to dive down into it, here I am, and sure enough, it is a class. So we're going to come back to this in a minute, but just wanted to highlight that for you. When you do see this type of usage, it's not something that is enforced syntactically by the language, but it is convention. And if you see this, then people who do Python packages that you use, and hopefully any of your colleagues will follow this convention as well. So we're going to be importing this class we call thread manager. And then if you look here, PyCharm has handily highlighted in a little bit different manner the thread manager usage that comes right after this. And if you were to look at what we are doing, and if you were to read this, you would say, okay, well, here I'm starting device threads, here I'm starting service threads, discovery for discovering hosts, monitoring hosts, start host thread, summaries where we go through the status data and we do hourly summaries. I have these remote workers that we talked about that I added recently. And we have this database maintenance, which I also added recently, where we go out and we trim the database of old entries so that we don't end up accumulating large amounts of data that we don't need and overflowing memory and all that bad stuff that might happen. So that's what we're going to be kind of doing here. Now let's start to talk about this. Here I'm using this class name that I have referenced, that I've imported, and then I'm having a dot, which is how we refer to things that are a component of the thing that's on the left. So here's my class dot, and then this name here. And if you were to look at this, you would say, well, here's a opening parentheses, and then at the bottom, here's a closed parentheses. You can see that PyCharm has highlighted that for me. That looks suspiciously like a function. And maybe this one here makes it a little bit clearer because we don't have the three different long verbose items there. We just have one item, the service monitor interval that we're passing in. This looks suspiciously like a Python function. And I'm going to tell you that it's not a function. It is actually a method. And if you're to ask me, well, what's a method? I would answer, it's basically a function. And that's exactly what it is. It's a function that is defined as part of a class. If I was to go down here and dive into this, don't get confused by all the other stuff, but look at this. What does this look like to you? It's looking like a function definition. And basically, a method inside a class, we're inside this class, if I can ever get to the top of it, this class thread manager, or inside thread manager, you'll see there's a whole bunch of these different functions that are defined. And as you might guess, I've used this word before, the function which is defined within a class, we call a method. That is language that is used in other languages. It's a word that's used in other languages, such as Java and C++ and other languages that do object-oriented stuff that deals with classes. So all this is it's a function call. We will call it a method. When you see on Stack Overflow or wherever you may be looking at stuff, somebody's talking about a method, you can just translate that into your mind and say to yourself, oh, that is basically just a function that's defined within a class. And so at our high level, we're starting device threads, of which if you were to look at this, you might think, oh, he used threads plural, and I have 3 different intervals. That probably means that we're going to be starting 3 different threads, and that's true. There's going to be one thread for monitoring devices. There's going to be a thread for gathering compliance information. That would be information about the OS version that we are using primarily, and also comparing the configuration to see if it's in compliance. And then we have this config diff functionality where we actually can compare different configurations from some amount of time ago. And that is what we're doing when we gather this configuration monitor interval. That's what that monitor interval. Why do we have different intervals? Well, device monitor, you probably want to go out and do that pretty frequently, maybe every minute, maybe every 5 minutes. Compliance monitor, things are not going to be changing quite that often. You don't replace the OS on a device all that frequently or do major configuration changes. So these two can be run maybe hourly or maybe even daily, whatever you choose. That's why there's different values. But for service monitoring, we're passing in the interval, the discovery interval. Remember, where did those come from? Just to remind you, those were what we got from our environment variables. So we gathered that information. We have some defaults, and we're actually using those when we begin to do this thread stuff. So in a typical web application, just to review, you're going to be sitting there most of the time and waiting for somebody to call you via these APIs. And when you do get a request, you're going to go and do something. But our application is not only serving that function, but it's also going out in the background and doing all of these things, device threads that are going to be running to do device monitoring, etc. Service monitoring, host monitoring, gathering summaries. These are all running in the background and they're all updating. What are they updating? Well, they're updating our database. Remember, we went and we created our database. So these things are going to be running in the background all the time. So let's begin to look a little bit deeper into what exactly is defined by Thread Manager, a little bit how it works. We're not going to do a deep dive, but we're going to look at it a little bit and give you a taste of what actually goes on and how we start all of these threads that are running in the background. Okay, so now we have a general idea of what's going on during this initialization phase. We're using this Thread Manager thing that I've defined, and we're starting these background threads. We have device threads, service thread, a discovery thread, a host thread, summaries thread, worker threads thread, and a database maintenance thread that's going to go out and do stuff. I've told you that it's going to be starting those threads and they're going to be running in the background. I have not shown that to you yet. And so what we're going to do now is we're going to dive into at a little bit of detail and understand a little bit more about this thing called Thread Manager. So I'm going to Control B, and here we are at Thread Manager. Now, for those of you that are advanced software developers, you understand object-oriented programming. You know what I'm talking about when I talk about static methods, when I talk about singletons, when I talk about referencing self, etc., etc. These are not things I'm going to go into right now. I'm giving you an overview of what this thing that is called Thread Manager is going to do for us. So please hold your commentary on this, or you don't have to even have to hold the commentary. You can ask questions if you like, but I'm going to go into this at a relatively high level. So for all of us, let's look first at this Python module, and you can see that I am importing a whole bunch of stuff, a whole bunch of things that are called tasks. These are classes. In fact, if I go and I do my Control B into this, you'll see that, yeah, sure enough, there's this class called device monitor tasks. So I've defined all of these tasks that are actually going to go and do the things that I want them to do. And we're not going to go into those details right now. That will be a subject of walkthroughs when we get to these. Obviously, there's a number of them: device, compliance, configuration, host, service, discovery, summaries, workers, database maintenance. We saw those as threads getting started, or we saw reference to that type of stuff getting started. So let me go at a high level overview of what actually is happening in here. So Thread Manager is a class that I've defined which is going to maintain information about all of the threads that I have created. Now you'll notice for every one of these there's going to be a task and there's going to be a thread. Like I said, we'll go into this in more detail later on. You'll see a little bit of what's going on when I show you the code. So let's go down. So there's device, compliance, configuration, etc., etc. So I'm going to use start host thread as an example to describe this because, as you can see, device threads are a little bit more complicated. They're actually not more complicated. They're pretty much exactly the same, but I'm doing 3 different threads. So let's keep it simple and just talk about this one. So here is my method name, start host thread. Remember, it's just like a function. I'm getting passed in host monitor interval, and I have a default value, as you can see. One thing that you'll notice is that this is defined as being a static method. What that means is that there isn't a separate instance that is going to be referenced when this function is called. If you've seen something in code that is object-oriented where there is something called self, then that is when it is not a static method, but it's kind of a normal instance method, and self, which is refers to the actual object instance itself, is going to be referenced. In our situation, there is just this one class, thread manager, and it has these one instances of data, these things that you see up here. There's no self associated with them. If you don't understand that totally, don't worry, just hang in there, and when we get to object-oriented stuff, it will make a little bit more sense, but just be aware that there's going to be one of these for the entire project. One service monitor thread, one service monitor task, etc. So down here in start host thread, what are we going to do? Well, the first thing that we're going to do is we're going to create a task. Now, host monitor task, that is something that I've defined, and that is going to be an actual instance of this class that we are creating, and we're saving a reference to it in host monitor task. And what I'm going to do then is part of how threading works, and we're not going to go into all the details of threading, but take my word for it. We're using the threading package, and we are creating a thread object, and we're passing in what is actually going to get run. And what's going to get run is our host monitor task. Remember, we created that there, and we're referencing this thing called monitor, which is actually a method within my host monitoring task. And the arguments I'm passing in are going to be host monitor interval. So if I was to go here, let's just bounce down just really quick. This is my host monitor task. Remember, I said that there was something called monitor that we were referencing. That's this right here, host monitor task.monitor. That's actually what is going to get called. And you notice what is inside this method. Well, while true, what does that mean? That means it's going to run forever, and hopefully this is self-descriptive, until we've been told to terminate. So it's going to go through here forever. It's going to get all the hosts, and then for every host, it's going to go try to ping it. And if it's successful, then the availability is going to be true. We're going to get the response time, and we're going to store all this eventually in the database. Okay, so we are going out, and this is what we're doing. Our while loop is going to just forever loop through all of the devices and gather their status. I'm not going to go into this in great detail now, but that gives you a taste of what is happening in these particular threads that we are creating. Now, the last thing that we do after we've created the thread and we've pointed it at where we want it to actually be executing, then we need to tell it to start. And so we're going to take that host monitor thread, which is what we created up here, and we're going to tell it start. Now, the last thing I want to say about, maybe it's the last thing, I'm not sure, about threading is there are many different ways to create threads, to initiate threads. You can run them, you can start them, you can do a number of different ways of doing this. I've chosen this simply because it's fairly easy and straightforward. You might have different ways that you like to do threading in the future. Don't think of this as gospel or the only way to do it. You can find plenty of arguments one way or the other for different reasons you would choose to do different threading. But I have been consistent throughout, so you can see that I'm doing basically creating the thread and then doing a start for all of these. So that is basically what our thread manager does. I should point out, as long as I'm on, let's see, where was my host? The other thing that we have is a stop host thread. I'm not going to go into that in great detail because obviously at initialization we're not doing this, but we are going to go through to our task and tell it to terminate, and then we're going to wait until it ends, and then we're going to set these back to none. So that's generally what this thread manager thing is. So let's go back to our initialization and look at this. So we start device threads, service threads, discovery thread, host thread. That's what we just looked at. Summaries, workers, DB maintenance, etc. That is what this threading segment of the initialization process is doing for us. Hopefully that makes some sense at a high level. I hope it makes sense to everybody at a little bit deeper level. If you have a little bit of experience, or maybe you're just getting your feet wet with this, then hopefully some of this is going to stick and you'll have a general understanding of what's going on. The bottom line is that towards the end, which is right here of our initialization process, is we are starting all of these background threads. And this is where all of the information that gets stored in our database is happening. These threads are running, gathering information, putting it into the database so that later on our user interface can grab the information through those views that we've defined up here. Okay, hopefully that's been a useful description of our initiation of all of these threads, and you're a little bit more have a little bit more understanding of what Quokka does during startup in this regard. I will talk about these, which are a little bit special, next time that we do the next walkthrough. Okay, let's quickly review what we talked about in this session. We talked about how what we're doing next during the initialization process is we are starting all of these background threads. And the way that we're doing that is we are referencing this class that I've defined called thread manager, which manages the starting and stopping of all of these threads. When we go down and look at it, we can see that it is indeed a class. We have all of these variables that are just associated with the class itself. And then we have all of these functions, which are really methods, because a function within a class is called a method. And we looked at the host one, but the others are the same. And we showed how we basically created a task to do what we want to do. We created a thread, and then we started that thread. Hopefully this takes you a little bit further down the path of understanding what we're doing. And yeah, enjoy understanding what Quokka is and how it does what it does.